An unknown distribution has a mean of 90 and a standard deviation of 15. All right, it's not known. I can't say that X is normally distributed with a mean of 90 and a standard deviation of 15. All right, I don't know that it's normally distributed. I don't know what the distribution is. All I know is that the mean of this distribution is 90 and the standard deviation of this distribution is 15. That's all I was given there. Mean, 90, standard deviation, 15. All right, we are grabbing sample sizes of 25 at random from the population, meaning that I'm getting 25 people collecting their data. I'm getting another 25 people collecting their data. I'm grabbing another 25 people and collecting their data. I'm just grabbing these groups of 25 people repeatedly. All right, that value there, 25, is my N. It's my sample size, 25. Write the probability question mathematically and then find the probability that the sample mean is between 85 and 92. The probability that the sample mean is X bar. It's not a regular X, it's X bar. That's our all the way from chapter 2, I believe. X bar was our sample mean. So in my probability statement, probability question mathematically, which I'm trying to stress so much, I'm asking you for these on assessments. You need to know how to write these. We want an X bar if I'm looking for the probability that the sample mean. If it was the probability that a randomly selected person, individual, was between 85 and 92, that would be a regular X between 85 and 92. But now we're talking about the sample mean being between 85 and 92. All right, you need to make sure you are writing the correct version of X. The sample mean is X bar. So we put that in there. There's our probability statement. All right, now we're going to go and use our calculator to actually find this. Okay, but this is for sample means. Again, I'm collecting these groups of 25, and all I'm really doing is I would be collecting just the 25, take the average, and then that average would get added to my list of data. Okay, and because we're looking at the average of a group, I'm looking at a new kind of distribution. Although I didn't know what the original distribution was, my updated distribution is normal. I'm looking at this. X bar is normally distributed with a mean of 90, same mean as the original, and a standard deviation of the old standard deviation divided by the square root of n. The old standard deviation divided by the square root of n. Old standard deviation divided by the square root of n. Now, I had said earlier that 30 is safe for n, all right? And I recognize that it's under 30 here. It's 25. We're going to take it. We're going to say that it's okay. All right, the results, if we were actually using this for something academic, might be questionable because you want your n to be big enough if you can assume this normal distribution. All right. So just keep that in mind moving forward. But this is our new standard deviation. You see how much smaller it is? The old standard deviation was 15. The new standard deviation is 3. If we wanted to write it, with that sub-index, this is mu sub x bar, this is sigma sub x bar. We're now talking about the mean and the standard deviation for the sample means. So when I go and I use my online calculator now, I'm looking, at a mean of 90, still, that didn't change. But instead of these numbers being spaced out potentially by 15ths, we are spacing out by 3ths. That's my new standard deviation. If I was using the empirical rule, I would be having to be asked about these specific numerical values. which I'm not in this case. 85 is going to be somewhere right in here. And 92 is going to be somewhere right in here. And we're shading between them. All right, so when I go to my online calculator, I have to make sure I'm entering this mean and this standard deviation. Since my probability question was about the sample mean, I don't want to use the original mean and standard deviation. I want to use the updated mean and standard deviations, the one that go with this specific sample mean normal distribution. So I'm going to open up. Remember that these are over on the left or on our modules under the text and calculators. I have that normal distribution calculator. I can open it up. I want to have a mean of 90 and a standard deviation of 3. All right, I want to be looking between two values, and I want to be looking between 85 and 92. Now this calculator is generic. So of course here, I can't point right now because I'm not in my notes app with my laser pointer, but there you see P of 85 is less than or equal to X is less than or equal to 92. Okay. I know it's not X bar written there. You can't change what's written on this calculator each time, but we are doing it for the sample mean for X bar since that is the mean and the standard deviation that we entered. We know that this result down here, this 0.6997, is for the sample mean, 0.6997. That was for the sample mean because we used the mean and standard deviation that goes along with the sample mean, all right, that we had to calculate ourselves there. So that's how the sample mean is going to work. That's just our first example. Obviously, we're going to look at more here. But remember, at any of these throughout Chapter 7, we're going to be asked for different things. If it's an individual, then we're using the regular X distribution, whatever that may be. If we're asked about the probability of a sample mean or an average of a sample or a group of people, then we're going to be looking at that X bar distribution. Right, and we'll get to the other kinds that we're going to look at in Chapter 7 here in just a minute.